We'll proceed in pseudo calculus problems. Okay, pseudo calculus problem we are pursuing, and we are still in phase of calculating the surface area of a circle, and through many ways. How many ways we can calculate the surface area of a circle, and means it is kind of uncountable. So many ways we have tried. We will try few more ways. So what was the idea? We calculated the surface area of a surface area of a circle through a way that just multiply height by width, and you get the surface area of a 2D shape. 2D shape, two-dimensional shape, two-dimensional shape, 2D shape means it has two sides. One is length and one is height. I'm sorry, one is width, one is length or height. Height into width is the height into width is the area. Height into width is the area of a circle, of a two dimension. With that, we have height and width. If I see the circle, okay, if I see the circle, then this is the width, that is x-axis, and this is the height, that is y-axis. Y into x is the area of circle. Okay, now someone will say why you are making us fool. Means y is, if I see the y, then minus a to a. If a is radius of the circle, if this is a circle and it has radius a, then y is minus a to a, x is minus a to a. 2a into 2a is the area of the circle, certainly. The area of the circle is y into x, height into x. Y is variable. Y is not constant a here. Y is here, y is different, here y is different, here y is different. Whereas x spans from minus a to a, x is independent. X is just going from minus a to a along x axis. Whereas if I see y at different x, height is different. So I cannot take one height into the picture. I have to take all the height into the picture. What is other solution? Take the average of the height, then you will get the height. That is another solution. Or simply write y into x. Y height into x is the area of a circle. Y into x is the area of a circle. And in that fashion, y is a function over x. Fx, f small f, bracket open, x bracket close. Y is function over x into x, and this is the net area. Now if I have multiplication of two items and one is function over another, and that is independent component, it turns up into integral calculus. Anyway, what is the area of circle? That is fx into x. What is your x? Minus a to a is my x. So fx into x, where x is minus a to a. If I change it into integral calculus, it will become fx into x into dx. And x was minus a to a, that will come as integral sign, snake sign, that is called in limit sign, and minus a to a. This will give the actual area of the circle, where y is the square root of a square minus x square, because y is changing over x, and that is the function fx. Function over x as far as y is concerned, that is the square root of a square minus x square. That is function over x. Square root of a square minus x square dx, x is minus a to a, will give the area of the circle, certainly. Means this is the way we start our discussion. Then we saw that height into width is, if I talk about the area of height into width, if I say that it gives the height into width, if it gives the area of a rectangle, area of a 2D dimension, if this is the height, then this is the width, and this is the origin. Okay, if this is the origin, this is height, and this is width. In that case, if this is origin, then this height point is x2 y2, and this point is x1 y1. then I can say x1 x1 whole square plus y1 whole square root, that is this length, and x2 whole square plus y2 whole square root, that is vertical length, is the area. Now, instead of that, if I say this is a vector and this is a vector, because x1 whole square plus y1 whole square root is a magnitude of a vector, that is x1I plus y1j. Similarly, if I talk about x2 whole square plus y2 whole square root, then that is also a magnitude of vector, that is x2I plus y2j. Now we have a vector, that is x1 y1, and b vector, that is x2 y2. If I calculate magnitude of these two and multiply, you will get the area. So area is not only height by width or y into x. Area is actually, people can, this is pseudo calculus. Start from a simple thing. Now people would say through vector also we get the area. That is magnitude of a width vector into magnitude of the height vector will give the area. That is magnitude of a vector, that is x1I plus y1j, into magnitude of b vector, that is x2I plus y2j. It also gives area. Now someone will come even ahead, not required. A vector cross b vector, you will get another vector called area vector. If you calculate magnitude of area vector, you will get the area. Not required that if you calculate the A vector magnitude into B vector magnitude, it will be only for the rectangle. But A vector cross B vector will give the area of a parallelogram also. So then calculate the magnitude of area vector, you will get the area. Okay, for this we proceeded like anything. Then we try polar coordinate, we try cylindrical coordinate, we try spherical coordinate. The idea was to find two vectors and make a cross of it, and you get the area. Anyway, now we are in phase of calculating the surface area of a circle. Surface area of a circle, and that surface area of a circle through a spherical coordinate system. Okay, many things we have talked from the series 1 to I believe series 8, the kind of in the pseudo uh, pseudo calculus problems in area calculation. We have seen too many things. We have done in numerous way calculating the area of a circle. Anyway, what we are trying to do now in a spherical coordinate system, that how we can find area of a circle through the spherical coordinate system. Consider that I have a sphere. If I talk about spherical coordinate, this is very heavy. I have a sphere. Okay, I have a sphere, and I am trying to calculate surface area of a circle. There is no circle here. How I can find circle? There are three coordinates. There are three coordinates into this sphere. One coordinate is r, radius. One coordinate is theta, and one coordinate is phi. There are three orthogonal components in a spherical coordinate system. Three orthogonal components. One is radius, one is theta, and one is phi. What is radius? Consider this is centered at the origin. Means if I say this is this is very heavy. If I say this is x-axis, this is y-axis, and this is z-axis. In that fashion, this is xy plane, x-axis, y-axis, and z-axis. Okay, then in xy plane, I can have in xy plane, if I have a if in xy plane, if I have a radius, and this radius, if I move in xy plane 2 pi angle, then this forms a circle, and this is called polar coordinate system. We tried finding out the area of this circle. This is radius, and make it move in 2 pi angle. So the angle it is moving, it called theta angle, and this is radius. But since it is a spherical coordinate system, radius will go vertical direction also. So if it is going in a vertical direction, and this is vertical from here, it will make an angle called phi. If it is in a horizontal direction and it moves like this, then it is making an angle called theta. So radius, 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 you are everywhere. So if I have a radius and from vertical it makes an angle, then this angle is called phi. This is one component of the spherical coordinate system. If there is a radius, if there is a radius and it is making angle theta in xy plane horizontal, then theta is another vertical component. How you can say that there are these three are the orthogonal components in a sphere r, theta and phi? How you are sure about it? There can be some, because it doesn't look like x, y, z. X axis, then perpendicular is y axis, and both perpendicular is z axis. Doesn't look like that. See, the radius is everywhere. Everywhere there is a radius of the sphere. Then all of a sudden from vertical you start saying there is a something called phi. Then all of a sudden you start saying from horizontal there is an angle theta. Okay, I can read in the book, but how you can prove that there are three orthogonal components? Okay, if I talk about the orthogonal component in a spherical coordinate system, if orthogonal component in a spherical coordinate system, then how I find orthogonal components, how I find orthogonal components in Cartesian coordinate system. So what is the de facto, the default shape in Cartesian coordinate system? What is the de facto shape in Cartesian? Cube. Cube is the de facto shape in Cartesian coordinate system. If I have a cube and if I take any surface, there are six surfaces of the cube. Two vertical surface and then again two vertical surface and two horizontal surface. It makes a cube. If I take one vertical surface, then there are two sides of the vertical surface. If I take another vertical surface, there are two sides of vertical surface, orthogonal side, orthogonal line. This line and this line, they make the vertical surface. If I see this vertical surface, then this line and this line, so both are same. Two 90-degree line we have found out. If I take like this and this side, then we have like this and this. This anyway we had found it in this only. In this side we had like this and like this, and on this side we have like this, that is common, and like this. So we have three orthogonal components we found at 90 degree. Now we'll take like this, the top and bottom surface. If I go top surface, then it is like this and like this, that we have already taken. Means there are three 90-degree lines are possible in a cube in Cartesian coordinate system. If I take surface of this, if I take surface of this, then what are the lines that cut each other at 90 degree? There is something called vertical arc. There is a called vertical. Everywhere there is a vertical arc. Everywhere there is a vertical arc. This is a line that is vertical. There, if I see, someone can say North Pole and South Pole. North Pole and South Pole can be connected through a line. Okay, this someone can say longitude of the earth everywhere. Now 90 degree to the longitude is this line, because I am talking about orthogonal components, right? 90 degree to the is this line. This is typically called latitude. Means I have one line that is on this plane and I have one line that is on a vertical plane. They cut each other at 90 degree. This is called vertical arc and this is called horizontal arc. Vertical arc, if I talk, then this vertical arc it is making, it is driven by a angle that is called theta. Theta into r is the vertical arc. If I talk about horizontal arc, it is driven by a angle that is theta. One is phi. Phi vertical arc is driven by phi and horizontal arc is driven by theta. This arc it is making it is r theta. Okay, what is your third component? Because it is a coordinate system, then there will be three components. It is coordinate system constitute a volume. Volume is three sides. What is your third side? Third side means, now I am thinking, what is third side? Third side should be orthogonal to both of these lines. Longitude line and latitude line. What is the third line that is 90 degree to both of them? Now, if I see the latitude, then radius is the vertical to it. If I see longitude, then again radius is vertical to it. Radius is vertical to longitude also, because radius goes everywhere in a sphere. From the center of the sphere, it goes everywhere. So the vertical arc radius is 90 degree. Horizontal arc also radius is 90 degree. Yes, radius is the third component. So radius, vertical arc and horizontal arc are the three components of a spherical coordinate system. Since the vertical arc is guided by theta, if I take vertical arc, then radius is constant. Phi is varying. Angle phi is varying. And if I take horizontal arc, then again radius is constant while arc is going on. Theta is varying. R, theta and phi, we say this is the three components of a sphere, the spherical coordinate system. If I take any point P on the sphere, any point P, consider this is centered at the origin. From center, if I draw a line, that is called position vector of this point P. What is the coordinate of this point P in spherical coordinate system? One is R, another is theta, one is phi. Theta and phi are angle and R is distance. So theta and phi has to be in distance. These are not mentioned in any of the book. So any point P will be, now if I, what is theta, what can be the arc for the theta and what can be the arc for the phi? If I take radius R any time, this radius R can be anywhere. If I take anywhere, then the vertical arc is R angle phi. Whatever angle phi it has made, that is the vertical arc. It is from R phi distance from the beginning point of the phi. Now, if I say R sine phi, it will fall on xy plane. And then here, if I move theta, then this arc is R sine phi theta. R I have to take only one. Either I take here. I cannot say this is R and then this is also R. Only one R I have to take. If I take R here, then R sine phi will falls on xy plane or theta R plane, and R sine phi theta will be this R. If this R is here, then R phi will be this R. So any point, if I talk in a spherical coordinate system, any point in a spherical coordinate system here, that point is R comma R sine phi theta comma R phi. That is the coordinate in a spherical coordinate system. If I take position vector, then R unit vector plus the way I say x, I, y, j, z, k, R unit vector plus R sine phi theta unit vector plus R phi unit vector. So that is the that I'm sorry. So that is the position vector. Okay, now what we are trying to find, we have calculated the area in latitude. If I cut this sphere in say at the like this from the flat, if I cut at the center, when it is centered at the origin, then I get a circle, and that circle has a radius a. A is the radius of this sphere. Everywhere A is the radius. If I cut exactly at the center, then radius A will be there. Pi a square is the area of the circle at the center. If I cut little up, if I cut at little up, then it will have a radius R that is varying. At the center, radius A will be there. If I go and up, anywhere I can make a cut. And everywhere I can say there is a radius called R that is variable. Radius R will keep changing and that is variable. And that is variable with the phi. Okay, means if when phi is zero angle, then we are talking about the top circle. The way phi is moving, we are talking about at that moment what is the radius. If phi is 90 degree, then we are talking about radius that is a, that is the radius of a sphere. If phi is go beyond, then again radius will start decreasing. So we are talking about r radius, that is a function of function phi. At any moment, at any phi, what is the circle area? We have brought this from many perspectives. Please watch our previous video. Now question is arising, what is the circle of what is the area of a circle that where, so here if I am trying to calculate the circle of a area of a circle, then phi is fixed. At any fixed phi, I can make a cut. Okay, this is a full is a sphere, and from the center of it, phi will start from the origin. Consider this point origin is inside it and at the center of it. If I take vertical, phi is 0. If I move phi, keep moving phi, I'll stick at one particular phi, and there I'll make a cut. And at that cut, what is the area? Then I move phi, then again I make. So every phi, every constant phi, what is the area? Then I can find the surface area of a circle in function of phi only. Now question is arising that what is the surface area of a circle if I make theta as variable? Makes sense? No, theta is, I'm sorry, theta as variable. Theta as variable means on xy plane I take a particular theta. At this theta, at this theta, I make a cut from the top and it will result in a circle like this. So if I take, consider this point is origin at the center. If I move like this at some theta, and then from top I make a cut exactly matching the theta. Okay, then it will form a circle like this. Make sense? This is this is x, this is this is x axis, this is y axis, this is z axis. So from x axis, if theta angle is 0, and if I make cut from the top, it will make like this. If theta angle is pi by 2, 90 degree, it will make cut like this. At any theta, if I make cut from the top, then it will make a circle like this. What is the area of the circle considering theta as constant and then phi as variable? Because if I take like this, if I take like this, then to make the circle, the phi angle will start moving like this, and radius will move from 0 to a, and phi will move 0 to 2 pi, and it will make a circle. Okay, in that phase, I don't know, phi will be 0 to pi or phi will be 0 to 2 pi, that we will see. And then it will make a circle. Phi is variable, radius is variable to make an area, but theta is constant. If I want the circle area in term of theta as a function of theta, irrespective of theta, we see the circle area is constant. But here, if I make flat surface circle area, then with the phi it will change. If phi is 90 degree, then circle is big. When phi is less, then circle is small. Cut will go down like this. But if we make top cut at different theta angle, the circle will be same. So there is no variation in the area of the circle as far as phi angle is concerned, theta angle is concerned. Anyway, what is the area formula that we have derived? The surface area vector is d of p. Consider the p is the surface area position vector. If there is a point P here, then P is surface area position vector. D of P, position vector means a vector that comes from origin and is passing through point P. This is called position vector. Now, if I take derivative of P, okay, if I take derivative of P, then it will give the surface. So, D of P is the surface area vector. D of P, what is P? R unit vector plus R sine phi theta unit vector plus R phi phi unit vector. Now dP by d phi R, because phi and R are variable, dP by d phi R into d phi R is same as dP. D of P, d of derivative of position vector, can be written as d of P by d of phi R into d of phi R. D of position vector by d of phi R. How much at position vector P, how much area is changed if I make 1 unit of area change in phi and R, one area. So it is something. Okay, okay, consider what I can say. Okay, consider that this is P and there is a phi. Phi R area is like this. Longitudinal area is phi R area. In phi R area, if I make 1 unit of change, theta R area was easy to understand. It's a flat was theta R area. and top was top. It is theta r or theta r sine phi, whatever it is. If P means if there is one unit of change in theta r, how many unit of change in area I see at P? That is dP by d theta r. If I say dP by d phi r in phi r, if I make one unit of area change, how many unit of area change I see in position vector P? So in that case, dP by d phi r into d phi r. Okay, this is one, but this will not give the actual area. If position vector is in pure spherical coordinate system, why it will not give the actual area? If I want actual area in one coordinate system only, if position vector is in spherical coordinate system, and if I divide it by d phi r and multiply by d phi r, the latter d phi r will become d phi dr. I cannot have two independent component in calculation of area in same coordinate system. Not possible. Wrong thing. Okay, if you want surface area through same coordinate system everywhere, then you have to go in calculation of volume. Then only you can say d phi dr. Then two independent component as differential will come into the calculus. Otherwise, this is wrong. So what is right thing? Right thing is that if I want area vector, then I'll make a cut here. Consider this is this point, at this point this is position vector P. I make cut in theta phi plane. I make a cut in theta r plane. Okay, theta phi plane means r is constant, and theta r plane, if I make a cut, then phi is constant. Okay, in theta phi plane, if I make a cut, if I take any point P here, then consider that point P is here. If I make a cut in theta phi plane, there will be a arc. If I make a cut in theta r plane, there will be an arc. At point P here, there are two arcs. One is in theta r plane, one is in theta phi plane. If I make cross product of vector representation of these two arcs, it will give me area vector at point P. What is the vector representation of these two arcs at point P? Okay, vector representation of one arc is r unit vector plus r sine phi theta unit vector plus r phi unit vector. Cross product with vector representation of another curve line, that is same as r unit vector r sine phi theta unit vector plus r phi unit vector. Now from one side we have taken an arc in theta phi plane. R is constant, means theta is variable, phi is function over it. I'll take out theta from here. It will become r by theta r unit vector plus r sine phi theta by theta unit vector plus r phi by theta unit vector into theta, because theta I have taken out. Cross product, I will take out, I'm sorry, theta r. Theta phi means phi is variable. Theta is function over phi and r is constant. Phi I will take out. R by phi r unit vector plus r sine phi theta by phi theta unit vector plus r phi by phi unit vector into phi. Bracket close into phi. Cross product. Now here I will take out r. Then r by r unit vector, r sine phi theta by r theta unit vector plus r phi by r phi unit vector into r. Now I'll convert division into, now if division into differentiation and multiplication into integral calculus, it will become dr by d phi, where r is constant in this side, dr by d phi r unit vector plus r sine phi d theta by d phi theta unit vector plus r d phi by d phi r phi unit vector. Bracket close. Okay, cross product d theta I am keeping now, d phi I am keeping now. Cross product with dr by dr means r unit vector plus r sine phi d theta by dr theta unit vector plus r d phi by dr r d phi, I'm sorry, r d phi by dr phi unit vector. Bracket close. D phi dr. First one is exactly dp by d phi. Second one is exactly dp by dr. If I say dp by d phi, it will be exactly like that one. dr by d phi, r sine phi d theta by d phi, and r d phi by d phi, and another one dp by dr. So more or less we came to same conclusion that area vector at any point is dp by d theta cross, sorry, dp by d phi cross dp by dr, d theta dr. Somehow it happened like that, not necessary. Now, if this is the area vector, if I calculate magnitude of this area vector, it will give the area in phi r plane. Okay, what is now? Now dr by d phi, first side r is constant. That is, someone will not get directly. If someone say area is dp by d phi r into d phi r, in first cross r is constant, someone will not get. So that way someone has to come through pseudo multivariate calculus. Dr by d phi 0 because r is constant. R sine phi d theta by d phi. Theta and phi are independent because they are orthogonal to each other. 0. R d phi by d phi. R phi unit vector will stand here. Cross product dr by dr r unit vector. R d sorry r sine phi d theta by dr. Here theta is constant 0. R d phi by dr 0. No variation. So the final area is r phi unit vector cross r unit vector. That will become r theta unit vector. Now if I take longitude area, if I cut from the top in the theta r plane, phi r plane, then we have now the area vector is r theta unit vector d theta d phi dr, r theta unit vector d phi dr. If I talk in that fashion, then phi, the theta unit vector, if this is the perpendicular surface area, then theta unit vector is in xy plane. I believe it will be theta unit vector will be in arc direction, whatever it is in xy plane. That is perpendicular to the top plane. So it is all right because area vector has to be perpendicular to the theta phi plane. So it is all right. So we can proceed now. In that fashion, the area will be r d phi. In that sense, it will become r square by 2 and r is from 0 to a square by 2, phi will be 0 to 2 pi. 2 pi. Pi a square is the area and it is not a function of theta. Okay, it is not a function of theta. If people remember the past video, then there in the when we were calculating the surface area in theta r plane, flat surface area, then it came as pi a square sine square phi. It was in function of phi because if you change phi, the surface area of the flat circle, here the surface area is different, here surface area is different. Everywhere, depending upon the phi, surface area will be different. But moving in phi r plane, vertical, if you make theta variable, surface area will not be different because we are getting surface area as pi a square. There is no theta here. So everywhere it will be pi a square only. Okay, we will try in I thought of finishing this today. We will try in Cartesian coordinate and spherical coordinate system combined hybrid model, that is IJK. Here we tried r, theta and phi unit vector, IJK unit vector. We'll try again theta r plane and we'll see the area vector. Please do not mind supporting us. +91 is the India country code, 94831 60610 is the telephone number. +91 is the India country code, 94831 60610 is the telephone number. Okay.